Welcome to a new video from the Parts channel. Well, I'm going to make a short video, but I find it very interesting. This week they brought us to the workshop a van that had power loss problems, and also it did not exceed 3,000 revolutions per minute. That happened at the same time that these warning lights came on. They are preheater light warning lights. This indicates preheater light, glow plugs, and electrical failure. They always go together. This is a Nissan Primastar van, 1990 DCI. As I say, when those warning lights came on, the owner of the vehicle noticed that he lost power and did not exceed 3,000 revolutions per minute. Sometimes, even when the speed dropped, the engine stopped. It is not. The most common thing is that it stops, but it can happen. And he brought it to the workshop for us to solve the problem. We put it into the diagnosis machine. And we got two errors, but the one that interests us is the below. The one above is P1815, air conditioning relay, cold loop. That is something else. It has nothing to do with that power loss. The one that interests us is P1815, access air circuit. That failure is what interests us. There is. When this failure occurs, this can be caused, for example, by a MAF sensor or flow meter that is defective or dirty. This failure can also be caused by an air filter that is clogged in. Sometimes it can also be an EGR problem, the EGR being very dirty, but in this case, P1815 is usually accompanied by P1814, and in this case, we only have P1815. So we checked that the air filter was quite clean. We cleaned the flow meter because it did have a little dirt, but the fault continued. So what we do is go to the turbo solenoid valve. Look, this is the turbo solenoid valve in this van, the one I'm pointing to. Here, the problem that it loses power and does not exceed 3,000 revolutions is because what the ECU does, when it does not have control over the turbo to protect the engine from possible overpressure, what it does is disconnect it. That is, it stops controlling electricity to the solenoid valve, and then you are left without turbo. And of course, when it stops sending electrical current, that is why the preheater light illuminates and the electrical failure. Those symbols, the first thing we do is check that it reaches vacuum. In this case, what we do is release the lower hose, which is the one that comes from the vacuum pump to the solenoid valve. And we observe that there was barely any vacuum. So what we do is check the entire hose, that it does not have any breaks or cracks, but it was perfect, and we realized that the vacuum problem came from the vacuum pump. Look, this one you see here is the vacuum pump. The one we installed is that the owner of a scrapyard brought us, used. He did not want to buy a new one. And we have installed it, and now it works perfectly. And the fault has been erased. The problem really is not with the vacuum pump, but with the check valve of the vacuum pump. This is the check valve. What this valve allows is to create suction. To create that vacuum, it does not allow the air to escape out. It is like a non-return valve. But these valves are not sold separately, and therefore you have to buy the complete vacuum pump. In this case, the client has gone to a scrapyard, brought us the entire piece, and we have installed it, and as I say, it has been solved. The problem came from here. Sometimes you can also observe something else. You notice that the brake is hard, that there is a problem with the brake booster, because through that sleeve, which is at the top of the valve, the vacuum reaches the turbo solenoid valve, and therefore the one that is thicker brings the vacuum to the brake booster. But in this case, nothing was noticeable in the brake booster. Well, here you have this short video. If it has been useful to you, then don't forget to give a like and subscribe to the channel.